Alright guys, we're going to be solving another question following up onto the previous video, question 53. And in this one, we assume that the pins C and F have been replaced by pins with a 30mm diameter. And the question is asking for overall factor of safety for the link CF. And very similar to the previous question. The only thing difference is that in the previous one, we have the diameter of the steel or each of these pins 20mm, and now we have 30mm, which means they can tolerate more shear stress. If you haven't looked at previous question, a lot of things are covered in detail in the previous one. Feel free to check that one out if you want to get very deep into the areas, all the tensions or the forces that we have in here. So we started with the free body diagram of the lower member in here, FEG, and based on the moment about point E, so we have the force in here and one force at E. Since we are interested in link CF, we consider one force that is going to be the resultant of the force in two links that we have. So we have one link at the front and we have another one in the back. So we consider FCF the resultant of these two forces. And based on our moment equation about point E, we found that our FCF was 39 kilonewtons. And what we are interested in here is the factor of safety, which would be the ultimate force in FCF over what we have for force in member in link CF, which is 39. So we had to find the ultimate force in link CF based on two things. So we are dealing first with the tension in the link or link CF, which we know is in tension. So we have the ultimate stress or tension in here, which will be the FCF ultimate force over the area. And as we discussed in the previous question, so the area that we are interested is the area where the pin is located. So we are dealing with somewhere in here, which is going to be something like this. And obviously we have another one in the back since we have two links. So the area that we are interested is these two links, or we have four shaded areas. And for finding that, we know that the dimensions in the question, it's 40mm and the thickness would be 10. And the only thing different in here is that the diameter of the pin, which is what we have in here or here, would be 30mm. So this will be 30mm. So this is definitely going to affect the area in here. So if you want to find the area, we're going to have the area of this rectangle. So it'll be something like this. So will be, the thickness is the same. So it will be 10mm by 40mm. And this part is 30mm. So the area of shaded area would be 40 times 10 minus 30 times 10. So basically we are finding the area of the big rectangle, this one. So 40 times 10, which is what we have in here. And we're going to subtract the area of this little one, which is 30 times 10, which is going to give us the area in here. So that's going to be 400 minus 300, or 100mm squared. And if we want to report it as meters squared, we have just 100 times 10 to the minus 6 meters squared. So this will be equal to, we have the ultimate shear tensile strength in the question. So it will be 400 megapascal. So 400 times 10 to the 6 pascal, or 400 megapascal. And if we just cross multiply these two in here, we can find our FCF. So 400 times 10 to the 6 times 100, 10 to the minus 6. And we're going to get the force in Newton. These two will be cancelled out. So it will be 40000 or newtons, or 40 kilonewtons. So based on this, we can find one of our factor of safeties. So the factor of safety would be 40. Oh, one thing I forgot in here is that, so I only found one of this, so this has to be multiplied by 2, so this will be actually 2. So the force in here would be 200. The area would be 200, and here we're gonna have 200. So we're gonna have it times 2 in here too, so that will be 80,000 Newton or 80 kilonewton. So 80,000 or 80 kilonewton. So we're gonna have 80 divided by 39 as our first one. So 80 divided by 39, that's gonna give us 2.05. So that's our factor of safety based on the tension in the link BCCF. And the other thing that we need to check is the shear stress in our pins. So we also have the ultimate shear stress on pins. So we're going to get another FCF ultimate here, and we're going to have different area. And the area this time would be the area of the pin. So we're going to have this pin that is going to experience two different forces, one from the link at the front, one from the link in the back, which we found the resultant of them, which was FCF. So the area that we have in here is the area of these two circles, which have the area of pi over 4 times d squared. D is 30 millimeter. That's the only difference in this question. We have 30 millimeter diameter. So 30 squared, and we're going to do 10 to the minus 6 in order to get it in meters squared. And again, that's the area for one of the circles. We're going to multiply this by 2 because we have 2 of these. And also we know the ultimate shear stress is 150 megapascal, or 150 times 10 to the 6 Pascal. So we can find the ultimate force in member in link CF. So 150 times 10 to the 6 times the area, pi over 4 times 900 times 2 times 10 to the minus 6. These two will be canceled out. And let's calculate this. We can actually cancel these two. So basically we have 150 times 450 times pi. So this is going to give us 212.06 kilonewtons, which if you find a factor of safety this time, we're going to have 212.06 divided by 39. And keep in mind that we have to have all of these two in kilonewton, so divided by 39,123, and this is going to give us 5.44 as the second factor of safety. So we're going to go with the least factor of safety because that would be the most vulnerable component in the system to failure. So it seems that now that we have a bigger diameter for the pin, the system has actually higher factor of safety, which means in this case we need to pick this factor of safety 2.05 as the final answer for this question. Again, the component that has the least factor of safety that we have would be the most vulnerable component to failure, so we have to stick to the least factor of safety in here in order to avoid compromising the system. So yeah, that would be all for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.